Hello YouTubers, welcome back. I am KD7TWW. I am a ham radio operator in the city of Boise, Idaho. And what we have here today is Bob Heil's, you know, that guy with the great microphones that we all come to love, and the sound technology that he develops. I didn't know until recently that he is a organ player. A very talented organ player. Anyway, on hand and on tap today is his pine board project. And we'll spend a few minutes, hopefully without repeating myself. This is a second take. And I'm getting better at this as I go along. But let's get started. I found this project on the interwebs. I'm not sure exactly how, but yeah, I do know how. I looked up Bob Heil, K9 EID, which is Kilo 9 Echo India Delta, and looked him up on QRZ.com. That's a ham radio database on the interwebs. And I was cruising through his page. I was curious about Bob Heil and wanted to look him up, so I looked him up on QRZ. Going down through his page, he starts describing this pine board project. I said to myself, that looks pretty interesting. I'm gonna go check that out. And I did. And the next 10-20 minutes will explain what it is and stuff like that. This will be part one of the power supply and preamp section on a pine board. So without further ado, let's go over to the schematic, and that is on a monitor behind you, and we'll swing over and start to dissect the schematic and the design. And hopefully I don't bore you within these next few minutes, couple minutes, and that we're able to learn something together. And I'm able to explain to you the topography, so to speak, on the design of this project. And in simpler terms, I'll try to be general on what stuff does. And okay, without further ado, let's go ahead to the monitor, which is behind you. I'm going to turn you around, camera, and we're going to go over to here. This is the schematic. And what you're seeing here, excuse me, is the preamp schematic. So what we're going to do first is go down to the power supply. And I'll explain the power supply, and then we'll move on to that preamp below. What we have here is our primary side with a bus bar. A bus bar is similar to that. I don't know if you can see it everywhere. You get the idea. It has terminals. You'll see more of it on over there. when I show you the project on a pine board, but that's basically a terminal strip. So basically you have this here, and that's the input. Terminal strip, fuse, switch, primary side, power transformer, secondary side, which puts out, you put in 110, 120, which is United States voltage for most of the 50 states. You have your secondary side, which is high voltage. Here you have your bridge rectifier, your first cap, dropping resistor, second cap. What these caps do in this circuit is this. Let's go back to this bridge rectifier. The bridge rectifier turns the AC component of the secondary side of the transformer, rectifies it to DC. First cap, excuse me. First cap smooths the peaks of the AC component coming off and the DC component coming off of the bridge rectifier. First cap takes care of that. Positive and negative. Dropping resistor. Second cap for further smoothing. And then you have a bleeder resistor, which is 33K R2 going to ground. And then you have your output B plus transmitter, which I'll show you in later videos. By the way, this is going to be part 1 if I didn't mention that. B plus preamp, 6.3 for the filament. This is a tube circuits. And you have your ground. This bleeder resistor is used as sort of a safety device to bleed off the high voltage off of these caps. And when you flip the switch off, that bleeder resistor drains these two caps. It really is designed again as a bleeder or a safety feature. You can get a pretty nasty shock off of this design if you touch it, and I'll show you that on the board. And this is a pilot light, shows that this circuit and this transformer is on. So basically what this provides is approximately 300 on the secondary side to the bridge rectifier, rectifies it, smooths it, drops the voltage some, smooths it again, or the peaks of the waveform on the DC and AC component coming off the bridge rectifier, and then you have a bleeder. And this is a CRC circuit. Cap, resistor, capacitor. So again, capacitor, resistor, capacitor. CRC circuit. Okay? Okay, moving on. I will explain about the preamp circuit. Sorry about the movement there, but we'll get through it. Okay, so this is a 12AX7 dual triode. It's a preamp tube. You've got to boost your microphone input unless you're using a key, which is a teletype or CW. CW is continuous wave. Or if you're doing Morse code, you don't really quite need this circuit, but for today's purposes, we're going to use a microphone for this 80 meter transmitter. You have your 2.5 millihenry choke here. Your first cap, which quiets the waveform going into the second cap, prevents this first tube from oscillation. Oscillation is a very on-off kind of thing. It's very disturbing for audio if you're going to speak with a microphone through the circuit. So first triode, there's a gain stage. This circuit here is an equalization circuit. So basically we have a bright, a flat switch, a bass, treble, and a volume knob. Volume knob, treble, bass. So this is already sort of preamp or boosted through the first stage. It goes to the second stage, and the increase is boosted again, and the output goes up to the top of the plate. Okay, the designation here is the plate of the second triode, first triode plate. So basically, the design here and the way this is put together is you have your output go through the plate, goes through this equalization circuit. It hits this first treble control, and treble goes to your volume or gain stage, and this adds, the bass control adds some lower frequencies into this circuit, and you can pretty much customize your sound input from this area. So again, your microphone, your first choke, first capacitor, second capacitor, first resistor. These three components keep this first gain stage from oscillation. Kind of like a fluttering sound. It smooths the input and output. Equalization goes to your volume, input, second gain stage, the bias, which is a 1K and a 10 microfarad 25 volt capacitor. So this bias is the tube of how strong or how much of an increase of a boost that the second triode provides. The combination of the bias and this third or fourth resistor again sets the bias of this tube. Here's a filter capacitor. It's a 10 microfarad 450 volt. That goes to our B plus supply, and that was above here. B plus preamp. And moving on. This is your second output capacitor. Keeps the tube from this tube, the second preamp, from oscillation. Your fourth capacitor there is to ground, and then you have your output. This output goes to your transmitter, and that transmitter will be probably in video 3 or 4. This first video that we have on part 1 explains the power supply and preamp. I'll move you over here and I'll show you how I designed and put this project on a pine board. Let me zoom you back out. There we go. Yeah, I know my desk area, my workbench is a mess. I don't know whose workbench isn't some sort of mess. So, and what we're going to do is we're going to cut this. This will be part 1. And next I will explain all these components. So I'll see you on part 2. Be sure to hit the like, subscribe, and look for part 2 next. Thanks for watching. See you in part 2.